I spent so much of my career both programming, running, setting up CNC machines. There was a certain amount of automation that really took the personality out of what I made. And it was fine. I mean, I was making, again, like beepers and everything from breast pumps to refrigerators, you name it. I've made a model of it. Um, there's an old saying that says the cobbler's kids go without shoes, because when he gets home, the last thing he wants to do is make shoes for his family. So what I was really looking for is an outlet for um, a more creative hobby. I was lucky enough when I started to work with some Swedish pattern makers that would make patterns for big castings. And before CNC, they did them all by hand. So I learned some really, really great modeling techniques, sculpting, joining techniques in wood from these old pattern makers. Now, I'm not going to say that I've never CNC'd a piece of wood, because it saves a lot of time when you want to make some really, elaborate surfaces, when you don't feel like, hand sculpting it out.
Well, I guess one of the things that I've noted when I've seen some of these old patterns is that I can almost tell by some of them the way that the blends occur, especially in the different filleted areas, that they're almost hand done. It's almost, there's certain things that were very difficult to replicate in a traditional CAD system. So tell me, Chris, in your early days, in your hand sculpting and doing everything else, was there a certain level of frustration once you moved into the CAD area, trying to get those types of blends and continuity the same?
The biggest frustration, I should say the biggest frustration, we all have jobs. We know that there's a lot of frustration with jobs, no matter what it is. But one of the frustrations that I ran into when I was kind of on the cusp of the hand modeling and going towards the CAD models, there was a little bit of time there where I was doing both. And SolidWorks, it's specifically SolidWorks. I'm just saying that. I'm not just saying that because I'm on your podcast, but SolidWorks especially made it so easy to put fillets on everything. Put chamfers on everything. Just automatic fillet, automatic chamfer, to the point where when I would get the model, there would be so much details on these models that I would have to really go through it and talk to the designer engineer and say, okay, which ones of these do you really, really need? And they'd say, oh, yeah, I'll do this. So CAD almost made it too easy to detail models. Whereas back before CAD, if you're drawing them by hand, to draw 12, 15, 20 different fillets or radii, especially in an isometric view, could be a little tiresome. So a lot of times I would see that these engineers would just skip that part. But now, especially, we're able to design so freely. I think somebody told me once a long time ago that they never wanted their CAD system to get in the way of their imagination. And I think that's really what CAD is now. I don't think, at least I can't think of an instance in my experience where the modern CAD system has ever stopped anyone from being able to express themselves.
Yeah, to me, it's interesting because with the advent of technology, right? And again, not giving away how old we are, um, but but starting, in the days of board drafting and then doing 2D Boolean CAD, and then you get into the parametrics, right? It used to be like, I'm going to be very rigid because I'm going to do just the minimum to get my thought to the next person, right? Because I imagine it in my head and I made it 2D stick figures just to convey that thought. And today it's a matter of, I can capture my entire universe of what I'm thinking, putting it in here. And now it's like, if I were to detail this out like I used to do, there would be so much information it would be hard for someone to capture, just because we put so much into it. Where I think, today, where you start talking some of the other things where it's like, okay, I have a 3D model, just let me do what I need to do on top of it, whether it's 3D printer, machine, or whatever. It's trying to simplify how much we can capture today. At least that's what it seems to me, when I see people draw these really complex shapes, and it's like, okay, how are you going to manufacture that? And it's like, well, I just hit the 3D print button and it's there. Yeah,
Uh-huh.
So
It's just like a CNC machine. Just press the green button. It does it all itself.
yeah, that's right. Just turn it to 100%, push the button, and walk
That's
away.
right.
Yeah. Yeah.
Well, that's actually a really great point. Some of the most brilliant mathematicians that I ever met were machinists. I'm not even kidding. Because like what you're saying, you're going to do the minimum amount you have to on the drafting board, which means maybe figuring out the space between dovetails, figuring out certain angles of ejector plates on a mold, or draft angles, like compound draft angles on a die. The designers, they would give you just enough information to figure it out on your own. So it would take the machinist so long to just go through and trig out all of these things. I think any machinist here that's listening they're probably nodding their head like, oh yeah, it takes a long time. And it's so nice with CAD now, like here's the solid model. Not only does it be like I can print it or whatever, but you can actually dissect that and get out all of the information that you need as a machinist for both setting up, manufacturing, and inspecting of parts.
That is a great point. I can't tell you how much and how often I'll actually use the CAD model to go ahead and just replace the typical mathematics that I'd used in the past to be able to get a location, cross section, just all kinds of information. An incredible capability.
I agree.
So you and I were talking a little bit before, Chris, about IMTS, since we were both there, and enjoying the hundreds of thousands of people that came through, and
the world.
Yeah. Walking through the CAD pavilion, being like, "Oh, you have CAD? Yep, we have CAD." So through that, you and I were talking a little bit about where the future is and where you see it going, and I just like your thoughts of IMTS. I could talk for days on it, but you got to tour it a little bit more than I did. So.
Yeah, I mean, I could go on for days. That IMTS, for those of you that are listening that may not know, is the International, and I always get this mixed up. I always say it's the Machine Tool Show, but I think it's Manufacturing Technology Show or something like that. But I like to think of it as the Machine Tool Show because I'm a machinist. It's in Chicago. It's every other year. It's enormous. They have a CAD pavilion. Now they have a 3D printing pavilion. They have the machines. They have tooling. They have everything. It is impossible to see the whole show in one day, and close to impossible to do it in two. So that's why Mike's saying that I probably saw a little bit more. Being in marketing, I was able to walk around a little bit more and see what was going on. But as far as technologies, this year was really, really interesting. I saw a lot of automation. There's a lot of robotic arms, cell machining, transferring of parts in between machines, but not just lathe to lathe, transferring from mill to lathe or lathe to mill, to cut down on the amount of manpower needed to manufacture things. That I think is really going to be the emerging technology going forward, is the automation. I think the reason for that is also because, as a lot of people know, the number of machinists that are available in the world is decreasing. Because the workforce is decreasing, I feel that shops of any size, not just the large shops, the big enterprise shops like Boeing or Lockheed or Halliburton or any of these, even the mom and pop shops at some point are going to have to integrate some kind of automation into their manufacturing system. It was really interesting this year. A lot of the machine tool dealers had these robotic arms moving parts around. Another really great. I'm sorry. Go ahead.
Chris, one of the things that I just wanted to mention on that note is we're working closely with Fanuc America, and we're working with a particular machine tool that they've got called a Fanuc RoboDrill, which is very similar to the machine that you're actually describing. It basically has a robotic helper that will actually, coexist between two different machines and actually load material. It'll load tools. So you can have tools delivered and it'll automatically do that. Some really robust technology. Is that what you were talking about a little bit earlier? Were machines similar to that?
Yeah, yes, I was. Maybe not necessarily a specific machine. There are some odd, like the RoboDrill machine that's a great example. And I actually saw one at IMTS and it was really great. That is definitely one that I'm talking about. Also, retrofitting. I mean, you may have, a old Fadal that used to make cannons for the Civil War or something sitting in the corner of your shop.
They're about that old.
Yeah, it's really, I mean, you can. I see in the future the integration between CAD CAM and robotics or manufacturing automation. All coming together, so someone in a shop can say, hey, I've got this old machine, maybe I have 2 or 3 of these machines, I need to set up some automation in between these machines, so almost retrofitting machines. And then at the same time, like the dual prong, the other approach is the new machines coming out are already going to be at least equipped with the capability of having that automation, like you're saying, like the RoboDrill, which is a great machine, by the way. What a neat little machine that thing is.
No, it is.
Well, I think that's where the confusion happens, right? And CNC equipment is a connected device, and I think that gets missed just because it's not new. Like we can all assume that a 3D printer is a connected device. Everyone gets that because as a print driver. But if a 3D printer is a CNC machine in the same way that a mill is, or a laser, or water jet, or plasma, but because of they've been around longer, they don't get seen as that. And I think where the future is headed to is you do have your CAD, you have your CAM, you have your platform management system, if you will, where I can determine, how long is the spindle on, how long is it off, that kind of stuff. But really what we're doing is we're just taking all these segmented technologies and bringing them together. And with the skills gap, I think some of the people in the future, they're going to be the web developers, the video game programmers. Those guys are going to be able to run those CNC machines because once they figure out that it's just code and communication, like it's really all adjacent technology, right? You have to be a machinist in some aspect, but in a lot of ways for, production companies, the biggest part of that is going to be connecting them and setting them up. The actual running of it's going to be taken care of because, the CAD CAM systems are going to automate that process, capture those rules, leverage the automation component of it. So I agree with you. I think it's not that the worker is going to go away. I think it's that the worker in manufacturing is going to change. It's going to be people that are higher level thinkers and more in the connected component versus what most people think of as a machinist, which is incorrect, that they just stand there and push the green button all day. But I mean, I could be completely wrong, but that's sort of what I see happening. I see the IoT component becoming a big part of that.
No, I agree with you. And I think, the line that you drew between CNC machines and 3D printers is excellent. When programming a 3D printer, it's all X, Y, and Z coordinates, just like on a mill, except when you're moving, you're actually leaving material behind on a printer, whereas you're taking it away on a mill. Now, the 3D printers work basically like you were saying on like a printer driver. And the CNC machines, for those of you that aren't really familiar, work on something called G code, which is just ASCII, just letters and numbers that the machine interprets and then makes the movements, the appropriate movements. I would say that one big leap forward would be creating a universal driver, if you will, for CNC machines, and to take that G code post-processing step out and being able to take apart and being able to throw it onto any machine. Or sorry, I shouldn't say throw it on. It's a little bit easier. It's simplifying it, but programming it for any machine and not having to worry about the G code being correct. So, and I think this all goes to exactly what you're saying, Mike. I mean, this all goes to automation. Making it easier for non-machinists to machine things. When when I was coming up, I learned how to read G code, but late in the last, I don't know, 10 years or something, I don't think I've ever I haven't handwritten G code. I mean, I know what it all means, but I haven't even really looked at it because the G code coming out of my system is so good.
Yeah, if there was an ISO format for G code to where,
Yeah.
if it was like we have a couple different fields and everyone sort of had to follow this script, I mean, you could make CAM programming as almost as easy as 3D printing. That is the one thing that 3D printers have is they came along later. So they sort of got the fact that we can make this simple by standardization. Where CNC machines going back to the tape days, they all sort of like to do their unique thing. I think that's the challenge, right? If we could ever get to that standard like we're doing with tooling today with the ISO tooling, man, could really come down to push a couple buttons and hit print or subtract.
That would be really great, wouldn't it?
Yeah. Yeah, I mean, we just need another 30 minutes and we can solve all the world's problems, right?
That's absolutely right. I think we need to change the name of this to solving the world's problems.
Yeah.
There's speaking of standards, I mean, there's a CAM standard. I can't think of it right now. Maybe John knows of it. It's basically a standard that all CAM systems adhere to. It's kind of a set of rules when making your CAM system. Things about everything, but maybe, cutter comp, when to turn it on, when to turn it off, what needs to happen before and after, and things like that. I want to say it's RS-232, but I know that's not it. That's the wire that connects everything.
Yeah.
But it's something like that, and I'll look it up, and maybe maybe we can find out before this podcast is over what I was talking about.
Yeah, I think that I'm not sure if you're talking about EIA or not. I don't know.
Yeah, I very well might be. I don't know. Or I could be making it all up. That's very possible too, because I never let the truth get in the way of a good story. That's for sure.
Yeah.
Well, I can tell you about RS-232 because that's what my Matsuura communicates on. So, I mean, if anyone wants to be enthralled by even and odd bits and all of that, we can definitely do a segment on that.
Very nice.
That's about a deep dive. Holy cow.
Yeah. Well, if we really want to take a step back, I do have a tape reader on the side of my Matsuura, so we could do a lesson on punch tape.
Gee whiz! Do you have like a brontosaurus in the back on a treadmill running that thing, or what? Like the Flintstones?
Yeah. And when it's cold, I send him south, and I bring in something that's a little more nomadic to the cold region, maybe a polar bear, but yeah,
a woolly mammoth, whatever.
Yeah.
I have to comment on that because one of the things that I got with my PathPilot controller that shocked me was the simple fact that it would connect out to a Google Drive. So I could actually be programming somewhere in my house, just drop it on a drive in the cloud, go out to the machine shop and just pull it right off the cloud. That was very cool.
Yeah. That's a lot easier than the days of trying to remember the boxes where you had to like pick your A, B, C and then go hit receive and you yelled at the guy at the other end like, okay, hit in. Yeah.
Go down.
That's
or halfway through it would just stop and then you'd see somebody over there fiddling with the box and you'd just be like, come on.
Yeah. That's right. Wait your turn.
That's right.
I remember one of the first CNC machines I ever ran was this desktop, like homemade thingamajigger that was some engineer on the East Coast had made. And it ran off of the 5-inch floppies. Well, I was actually doing surface milling for barbecue grill tops. We were doing a lot of foam just to do side and stuff. We had to take, I think it was 7 or 11, I know it was an odd number, of these discs and just sit there, and as soon as one was over, pause the machine, put the next one in, start the machine again.
Yeah.
Sober, pull it out, put it in, start the machine again. I mean, it was crazy. These kids these days, they have it so easy. I tell you.
Oh gosh, I can remember being first of all, they were NC machines. They weren't even computerized. They were NC.
Right.
And they were all driven by Mylar tape and tape readers. Really, gosh.
It is funny like that too, because like we all come from the era of like we're concerned about efficient code and clean code and like streamlined stuff, right? But when people program today, it's like, if it's another couple thousand lines of G code, yeah, it's okay. The controller can handle it. My machine can handle it. Like, just drag and drop, like you were saying, John. Just, it doesn't matter.
Well, you've got sequence numbers now that go out 5 and 6 places, and some of the 3-axis code now, if you include n numbers, they'll use up all those numbers, and they'll start to double back at 1. And it's no big deal.
Yeah.
It's crazy to me.
It is crazy.
Yeah. It's funny too. Speaking of software, I don't make it seem like, back in my day, blah 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 blah. But it's funny. I'm sure a lot of people listening, and definitely the three of us can remember when, we would go to calculate some kind of calculation, whether it was a tool path or maybe a simulation in engineering, and we would literally hit go and go out to lunch because it would take so long to calculate. Yeah. And now I hear customers saying, "Oh, this takes too long to calculate." I'm like, "All right, well, take a stopwatch. How long is it?" They're like, "Oh, it's 16 seconds." I was like, "Oh, come on."
Yeah.
It's really changed since then. Expectations have increased.
I can remember in the late 80s, early 90s, some of the 3-axis toolpath projections and the amount of time it would take would just be phenomenal.
Oh yeah.
Well, and you're talking 3-axis machines. I mean, now there's 7-axis IntegrXs, and we're talking connected robotics and all their positions and movements. Like, and the complexity of what you draw is even more.
Oh my gosh. Yeah, for sure. I mean, there's the, what is it? I forget the exact machine, but they have one with an indexable tailstock. So you've got dual spindles, dual tool holders, dual spindles, dual turrets. Dual turrets, dual spindles, and now you have the spindles themselves moving on axes. Like, imagine trying to